Hi, everyone. Welcome to this SUSECON Digital presentation. This one is on SUSE container and application platforms, roadmaps of the products in that portfolio, those being SUSE Cloud Application Platform and SUSE CaaS Platform. I'm Troy Topnick. I'm the product manager of SUSE Cloud Application Platform.
And I'm Roger Clarice. I'm the product manager for SUSE CaaS Platform.
And on today's agenda, we're going to look at the roadmaps of both CaaS Platform and Cloud Application Platform, and then also look at the SUSE Stratos Console roadmap, which kind of ties these two products together.
We're organizing SUSE's efforts into three main areas, and this is throughout our product and services line. We aim to simplify how you run your business, modernize, change your business to be more effective, and then accelerate and scale your business and make you more agile and able to innovate faster. Within the portfolio, the themes that we're aiming at are ease of use and management, multi-cloud and multi-cluster, and hybrid infrastructure. These are overall design goals. We're going to talk more about some of the specifics. When we look at simplification, we want to make the infrastructure easier to manage. Well, in order to manage it effectively, you need to know what's going on and know when there are issues. So we're improving monitoring and alerting. We've introduced backup and recovery, backup and restore rather, and disaster recovery to make business continuity more effective. We will be growing how we integrate storage into the portfolio and managing security certificates more effectively. The idea here is to take these common and complex tasks and make them more error-proof and simpler to accomplish. To modernize, we will be providing a common user interface through which multiple clouds, multiple clusters, and the multiple products in the portfolio can be managed. We'll make it possible to improve the resilience, make your applications more secure, and have observability not only in individual clusters or individual apps, but across applications by integrating a service mesh. One of the things that we're finding is that people are migrating applications, but they still have many in virtual machines, and we are aiming to simplify this and modernize this approach by letting you use a single control plane to manage both your containers and your virtual machines. And we're seeing more and more use cases as AI and machine learning are used in more and more areas of businesses, that there's a requirement to support accelerated compute here, and GPUs are the tool for accelerated computing. Now, in order to make the business scale more effectively, some keys to this, being able to deliver rapidly with agility, are continuous integration and continuous delivery. So we will be improving productivity in that area. We'll make it easier to bring in services such as databases more rapidly through Marketplace. We'll be integrating more parts of the development process itself, that is, Git repositories and an IDE in which you can develop. And we'll be adding yet another profile in addition to the past capabilities of Cloud Application Platform, adding serverless computing capabilities as well. Let's take a look now in more detail at SUSE CaaS Platform. This is probably the first time you've seen a roadmap that looks like this, so I want to talk very briefly about it. When we say, for example, that something is delivered in release 4.0 or 4.1 or 4.2, SUSE CaaS Platform itself uses continuous delivery. So we may deliver features in 4.1, but we may also deliver features in 4.1.1 or 4.1.2. Actually, we have delivered features in 4.1.1 and 4.1.2. So when I say 4.1, for example, that means the entire period reflected by that arrow. It could be 4.1, but it could be 4.1.1 or 4.1.2. Okay, let's take a deeper approach. We released SUSE CaaS platform version 4 back in September. We modified the architecture significantly. We built on the command line first. We updated the container host operating system. I'll talk some more about that soon. And we changed our container engine. I'll be diving a little deeper into all of those. We've updated the Kubernetes release, as we will do in each release. The main feature of the .0 release is the new quarterly release of Kubernetes. In the 4.1 period, not only did we upgrade Kubernetes, but we added Prometheus and Grafana for metrics, visualization, and alerts. We added some networking capabilities. We started a tech preview of Kubernetes support in the Stratos Console, and we released a preview of AWS support, that is the ability to run SUSE CaaS platform on instances in AWS. We'll continue through 4.2, 4.3 to update our Kubernetes. We've added support on KVM. As I said, we've added backup and recovery. We will expand the public cloud support, make them officially supported, and add Azure and Google Cloud, automation of certificates, a new ingress controller that will be integrated with the eventual service mesh capability, and support for GPUs and more powerful integration of storage, whether it's our own SUSE Enterprise storage, it's any storage connected to your VMware infrastructure, or it's a third-party storage array that has a CSI driver. We will allow vendors to certify those for compatibility. In version 5.0, we will be upgrading the operating system we're running on to SUSE Linux Enterprise Service Pack 2, continuing to upgrade Kubernetes, and here we will be bringing out the VM orchestration as well as the full service mesh capability. And it's a little aggressive, but we will try during this period to bring out something that is a new feature in Kubernetes, which is dual stack networking for IPv4 and IPv6. So when we were building CaaS Platform 4, we had goals that we heard from our customers and from our development teams. We wanted to make it possible to use the familiar SUSE Linux Enterprise management process and tools to update the operating system and SUSE CaaS platform. We wanted to maintain as much uptime as possible and be able to update the cluster without having to reboot the cluster to take it offline. We've effectively done that by introducing containerization of the components, which in fact allows us to upgrade the Kubernetes installation without even stopping applications or draining nodes. We had a lot of complex salt in the installation framework, and we decided to focus more on improving the upstream framework and adding a wrapper command that would make that more efficient. We've removed the need for a dedicated admin. We were aiming at removing the need for a dedicated admin node, making it possible to take the security capabilities that we had applied via policies for the applications and extend those policies to apply to the network. We wanted to make it easier for people to install multiple clusters or to install clusters through another automation tool by making it scriptable and non-interactive. We had previously delivered containers as RPMs. We want to make those possible to deliver in a more cloud-native approach from a registry, and of course adding the observability capabilities, monitoring, and centralized logging. So the changes that we made in the architecture were, first of all, going from our dedicated micro OS flavor of SUSE Linux to SUSE Linux Enterprise Server, on SP1 in traditional mode. Our aim is to bring back also the transactional mode over the next year or so. We replaced custom installation framework with the upstream kubeadm, and we added a new wrapper command called Scuba, and that did two things. First of all, it made it possible to do cluster-wide operations as a single operation. So for example, I could upgrade the cluster or update specific apps in it by issuing a command for the whole cluster. Also, generally interacting with kubeadm will have a bunch of setup steps, the kubeadm command, and then some post steps. We put those right in Scuba so that it's really a single command. You can now bring up a cluster from any Linux desktop or other server, and that same node can be used for any number of clusters. So it doesn't need to be dedicated anymore. You don't need one admin node per cluster. And we did a quick update rapidly from 1.10 all the way to 1.15, and now we are shipping every quarter in approximately 90 days so far from upstream. So far it's been a little more like about 100 or 110, but that's our goal, to balance rapid innovation and stability. We changed our networking by replacing the Flannel plugin, which was flat networking with no policy, with a plugin called Cilium. Cilium enables network policies and more complex topologies, but one of the most important things about it is it leverages a new kernel capability called eBPF, and that allows us to implement those policies at very high performance and low latency in essentially sandboxes in the kernel. We've delivered the container images now via the SUSE registry, so no more get it as an RPM and unpack it. And we've implemented centralized logging in CaaS platform via our syslog, so it's compatible with standard Linux logging tools. We make it possible to log and separate the OS itself, CaaS platform, and the application pods. Because these logs are in standard formats, they can be exported to operational intelligence and log management tools such as the Elastic Stack or Splunk. And we've also released and supported Prometheus and Grafana, providing monitoring and dashboards for visualization of what comes out of those monitors. So what you gain here, first of all, non-disruptive update. You can do the full update without rebooting. We can track the SUSE Linux Enterprise Server service packs very easily by being an add-on module to SUSE Linux Enterprise Server. And by using kubeadm, we fit better and can take advantage better of upstream components, and it provides a more flexible approach to the work. Now let's look at a couple of key features. One of them was that in version 4 and going forward into version 5 and beyond, we're using a new runtime called Cryo. The purpose of this is, using Docker before, we used the same tool to build, to deploy, and to orchestrate containers, run containers rather. And the problem with that, the challenge with that, is it makes a tool that's very heavyweight and isn't built to be integrated into Kubernetes. Cryo was built to run in Kubernetes. It runs more efficiently, and it serves only one purpose, which is the running of containers. And there are other tools provided in SUSE Linux Enterprise Server for building containers in the container module there. Because it's lighter weight, it offers better performance, it's easier to maintain, it's easier to debug, and it uses the standard container interface called runC, so that as we go forward, it will be possible to also add some special purpose runtimes for things like scientific workloads or secure containers. Now let's look at what Cilium does. Cilium makes it possible to specify policies in terms not only of IP addresses and ports, but in terms of the name of the Kubernetes service, in terms of DNS names, so they're more applicable to environments and easier to manage. So when you change a node's address, but you keep its name, you don't have to change IP addresses. It's aware of protocols. So you can write policies that aren't on, say, port 80 and port 443, but you could write a policy for HTTP, and whatever port we see an HTTP connection on, those will be applied. Using BPF provides a much more optimized control plane, higher throughput. Most of all important, Cilium is transparent to applications. Two interesting features that you can take advantage of, multi-cluster routing and universal encryption, allow you to encrypt between instances of applications, different applications, between clusters. And these are basic features that you'll be seeing later in Service Mesh, but you can take advantage of them right now, right in Cilium. So now that version 4 is well underway, we're going to be releasing 4.2 when we're recording this in April. You'll be seeing it in May, by which time 4.2 is out. We will further go down the path of simplifying, modernizing, and accelerating by enhancing Scuba, by working on CI/CD integrations, making it possible to deploy multiple clusters with single API, declarative API configurations, providing even a better single pane view across the stack, being able to use more modern networking with more application-specific control of it, and accelerate with the support of AI and machine learning workloads with GPUs and better management integrated of VMs and containers. And with that, I would like to hand off to Troy to talk to you about SUSE Cloud Application Platform and the SUSE Stratos Console.
All right, thank you, Roger. So SUSE Cloud Application Platform is a platform designed for developers to be able to accelerate their application development and deployment process based on Cloud Foundry and other supporting technologies. I'm going to go right into what this means in relation to CaaS platform and other Kubernetes platforms, in that the Cloud Foundry framework, more specifically called the Cloud Foundry Application Runtime, is fairly well established in the industry as platform as a service software based on the Heroku or Google App Engine model of platform as a service, sometimes called application PaaS. It's been around since 2011. And SUSE has taken the innovative step of containerizing it and packaging it for Kubernetes. We did that a couple of years ago. We released Cloud Application Platform 1.0, and we used an architecture that complied with the Cloud Foundry Foundation's certification guidelines, which meant we had to package all of the components of Cloud Foundry for Kubernetes, and they all had to be included for it to be a certified distribution, which Cloud Application Platform is. This means that our architecture followed the virtual machine-based architecture of its predecessors and had these things called Diego schedulers. So what you see here in the blue boxes are the roles, some of the roles of Cloud Foundry system. And we see the user applications inside these Diego boxes. Those Diego cells are actually running as pods in Kubernetes in Cloud Application 1.0 and later. And they are, in fact, schedulers. Diego pods actually schedule applications much in the same way that Kubernetes schedules pods. This design is in place because Diego predated Kubernetes and had reached maturity before Kubernetes was mature enough to do some of the things that we expect it to do now. One of the most important evolutions of Cloud Application Platform and the Cloud Foundry distribution underneath it is the move towards Kubernetes native application scheduling. Now I'm going to use some terminology that's very familiar to people in the Cloud Foundry community, but might not be familiar to people who aren't in that community. So what we've done here with the new architecture is we've replaced the Diego cells with a scheduling component that plugs into what we call the cloud controller, or in this case it's shown by the cloud controller API, with something called OPI, the orchestrator provider interface, which will allow us in future to be able to schedule applications on any container scheduler. But right now we're focusing on Kubernetes, and that project is called Irene. These are projects that are happening upstream to modernize Cloud Foundry and provide a sort of renaissance for that community, moving it into the Kubernetes world and bringing Kubernetes users to that community. So the new components in Cloud Application Platform 2.0 draw from these innovations. We have the Quarks CF operator. Quarks is a team of SUSE engineers working upstream with some other partners on lifecycle management of BOSH releases. BOSH is, of course, this orchestration framework for Cloud Foundry, which dealt with virtual machines. Now we've made Kubernetes operators to port that functionality to Kubernetes. So Quarks, CF operator, provides a lot of CRDs for Kubernetes to manage life cycles and manage configuration. Most recently, SUSE donated to the Cloud Foundry Foundation kubecf. What we saw in the previous slide as SUSE Cloud Foundry, SCF, has now become kubecf, a first-class citizen of the upstream community. So these three components represent some of the advances that are going into Cloud Application Platform 2.0. Let's take a look at the roadmap. The 1.x series has been around for a while. As I mentioned, 1.0 was released a couple of years ago. Our latest in-production release is 1.5, patch release 1.5.2. In that release, we did the first technical preview, or actually maybe the second technical preview of Irene, which got it closer to feature parity with the Diego scheduler. This is the release that our customers are using in production now. The Helm UI was released. This is for being able to browse Helm repositories and deploy them directly to the Kubernetes API. We increased the usage metering capabilities by adding a Prometheus exporter to the Stratos metrics chart, which goes along with the Stratos metrics to provide details of usage on the platform. Looking ahead to 2.0, which will be coming along very soon indeed, the major innovations are the CF Quarks operator, the CF operator. This is going to provide us with better lifecycle management going forward, and updates to Stratos. You can see that we are looking for a 3 times a year cadence to provide updates in 2.1 and 2.2, 2.3, and beyond. But I've actually broken this out in the following slides. So why don't I talk about these innovations as they come. So coming very soon in May is kubecf. This is, as I mentioned, this upstream project, which has got a lot of traction and a lot of press as being a great way for people to get started with Cloud Foundry application runtime on Kubernetes. This is now the new basis for the Cloud Foundry functionality within the Cloud Application Platform. Quarks, as I mentioned, CF operator that provides the operators of the platform with smoother upgrades. Things that in previous upgrades would have had to be managed manually or required a little bit of manual intervention during the upgrade can now be handled automatically. So Helm upgrade will smoothly transition between point releases. Irene continues to progress. We are not recommending it as of this moment as a production workload scheduler. It is doing very well, but there are some stress testing and some feature parity with Diego that we would like to see advance a little further before we call that production ready. So we're hoping 2.1 for Irene, depending on upstream progress. Lots of great innovation in Stratos that goes along with the CAF 2.0 release. I'll talk about that a little bit later in the Stratos specific slides. Our public cloud team at SUSE has been hard at work making it easier than ever to install SUSE Cloud Application Platform on public cloud hyperscalers like Azure and Amazon. Most recently, we've released a marketplace image for something we call Blue Horizon, which allows you to use a web interface to configure a deployment not only of Azure AKS, but the Cloud Application Platform deployment on top of it as simply as possible using lots of sensible defaults and a nice intuitive UI for driving a Terraform deployment on the public cloud. Work is underway now for a similar port to Amazon EKS. This lives alongside the Amazon EKS Quick Start, which is already out in the market. Coming up in August, we believe, Cloud Application Platform 2.1. The major focus for 2.1 is on expanding and solidifying the application data services that are available as part of Cloud Application Platform. We have a broker in our current release called Mini Broker, which deploys database service instances to Kubernetes on demand for the users of the platform using Helm. The services that it deploys currently are from upstream chart repositories, from upstream maintainers, and they're not officially supported by SUSE. The broker is, but the services are provided from upstream. Going forward, we want to create SUSE-supported data services and images that we can bundle with Cloud Application Platform and work with partners to expose their Helm charts that they can support through our marketplace and through our Mini Broker. To do that, we need to make some updates to the Mini Broker, a project that is upstream in the CNCF Kubernetes incubator. And we work on with Microsoft. We have a lot of updates pending, not the least of which is the port of Mini Broker to use Helm 3. We're starting investigative work now on integration, close integration of CI/CD systems with Cloud Application Platform. We have some white papers available now on how to integrate a couple of CI/CD systems with Cloud Application Platform. We'd like to bring that integration a little bit deeper and choose one of the Kubernetes native CI/CD systems to be a first-class citizen in Cloud Application Platform. So expect to see some technical preview features and possibly an embedded CI/CD system with the 2.1 release. Many of our customers have been asking for assistance in creating reports so that they can in turn charge their customers. We sell a lot of Cloud Application Platform to cloud hosting providers and other parties that are in fact providing platform as a service to their customers. To do that, they need to be able to report in the CF Cloud Foundry organization and space and user levels. So we are going to provide some dashboards that can be used with Grafana to provide that information. With each release, we're going to be increasing the number of Kubernetes features that are exposed in Stratos. And with each release, we are going to be looking more closely at the Cloud Foundry v3 API updates to see what implications those have for Stratos and the rest of Cloud Application Platform. Some great functionality being exposed in the new Cloud Foundry v3 API as those features become more mature. Further along, we want to expose those CI/CD features that we've been putting in tech preview and deepen the integration with Stratos. We want to continue to expand the service catalog, not only with SUSE-supported services, but also through a partner ecosystem. And along with the CaaS team, we need to expose logging and observability of the Cloud Foundry platform as well as the Kubernetes platform. Indexed logs and aggregation through a nice, easy-to-consume interface that will work with either CaaS platform or cloud application platform or both. As mentioned on the CaaS platform slides, serverless is, or in the previous slides, serverless is another area that we are going to expand into. Obviously, the platform as a service model is extremely good for developing microservices and for accelerating development in an enterprise, but we're seeing a lot of movement in the industry towards consuming ready-made functions through a function as a service framework. We have a lot of the technology in place within the platform already to provide these features. One could argue that Cloud Foundry is a serverless platform, but for the prepackaged function as a service library, we're going to look at some other frameworks to see what we can adopt in the platform as smoothly as possible to integrate closely with the Cloud Foundry workflow that our users expect. Moving on to go into a little bit more detail about the web UI that unifies CaaS platform and cloud application platform in our container and application platform suite. So SUSE Stratos Console is designed to be a multi-API consumer. It is a web interface that connects to REST APIs. And because it is designed this way, with a proxy for API communication, we have been able to expand it not only to be the interface for CaaS platform, or not only to be the interface for Cloud Foundry, which it was initially, but also a Kubernetes, thus CAP and CASP. Developers will see a view of this platform that matches their role-based access control, so they will use it to deploy and manage applications. And the administrators of the platforms will use it to manage Kubernetes directly and to manage Cloud Foundry, to control the quotas, to control which build packs are available, to basically control any of the things they can do with the administrative APIs. We have just released Stratos Console, SUSE Stratos Console 3.1. Shortly after 3.0, so I'm listing some of the changes together here. One of the big pieces of work for Stratos Console 3.0 was moving to Helm 3. Helm 3 notably changed the architecture of Helm to remove a server-side component called Tiller. Some people regarded Tiller as a security flaw in the design. Perhaps rightly so. It gave permissions to a role that's running in Kubernetes. That's now gone. It's now a client-based utility, and the permissions are controlled by the user that is driving the interaction with Helm. Likewise, in Stratos, though it was a lot of work to implement, it now makes things much simpler. We have this wonderful side panel preview of Kubernetes resources. When you dive into a pod, it'll pull out a side panel that will show you the configuration for that pod and give you a link to view the metrics over time from that pod, which is delivered through a special Prometheus database in a deployment called Stratos Metrics. The workloads view was taken from the initial Helm tech preview. It's now a top-level view of Helm releases deployed to any given Kubernetes, and you can drill down into that and see what configuration it was launched in. The Helm chart improvements of the deployment itself, all of the software that I'm talking about is deployed using Helm charts, and we made some fixes and some cleanup in those. We can now have Stratos connect to an external DB rather than providing its own on Kubernetes. So if you have a high availability database where you want to connect Stratos, you can do that now. And we've improved the error messages for debugging purposes. Coming up in the next release, we want to be able to edit endpoints that have already been created. Stratos, as I mentioned, is a multi-endpoint client, so we can connect it to multiple Cloud Foundry endpoints and multiple Kubernetes endpoints. Now we're just making it possible to edit those endpoint definitions after the fact. we are going to have it showing SSL certificate warnings to let you know when expiries are going to happen. Change the pod configuration of Stratos itself so it can be deployed in a high availability fashion. Integrate it with Helm Hub so we don't have to individually point to Helm repositories, but we can point to the Helm Hub and search that. Support Helm Upgrade. Right now we have install and delete, but we'll add Helm Upgrade and all of the configuration changes that will entail. Make schema support for Helm install so it makes it a little easier to see and browse and control the values. One of the Stratos developers showed a really cool innovation in exposing third-party observability tools in Kubernetes within Stratos, and so we're going to show a tech preview of that in Stratos Console 3.2. Being able to run those security audit tools and have the results appear in Stratos where it can be easily understood. Kube Terminal is another really cool feature that was shown in a Cloud Foundry Summit a while ago. This brings up a web-based terminal with kubectl pre-configured for the particular Kubernetes cluster that you're connected to. As always, we are integrating Cloud Foundry v3 API features as they come in and making changes as it is necessary to do so. And we are going to work on more CaaS platform integration, specifically exposing labels for pending operations. Into the further future, and a lot of these things will change as we get into further releases. CI/CD views and workflows are still in the investigative phase, so we'll see what they look like when they arrive. Elastic Stack integration for log analysis is key for our customers. A container registry interface, that will be work done in conjunction with CaaS platform because both platforms need this functionality. Localization work, eventually a Git interface, and evaluating the various Git interfaces that are available to us. KubeADM and Scuba UI functionality, etc. UI for Istio, which is likely going to replace Nginx Ingress as our ingress controller of choice. And lots of feature requests. So you are encouraged to contact either Roger or myself or other members of the SUSE team to let us know what you would like to see in this product. And as we can see, there's many, many more feature requests than I can get into, but each of these gets evaluated. So sometimes we'll see some very good feature requests come in. With that, thanks so much for joining us and attending the SUSECON Digital presentation. We hope you've enjoyed listening to it as we've enjoyed presenting it to you. Bye for now.
Thank you again. Yeah, thank you again. And remember, there are other presentations available in SUSECON Digital in the area of container and application platforms. And we encourage you to view them and enjoy and learn. Thank you so much.